Video instruction for the installation of a modular autonomous power supply system for shared spaces and remote locations. Due to the full-scale invasion and shelling of Ukraine's energy infrastructure, Ukraine has faced massive electrical power outages. At some point, we realized that such dangers of being left without electricity due to war or other emergency situations are a reality today, not only in Ukraine, but also in other countries around the world. Currently, there are a significant number of solutions for individual households. However, the issue of providing electrical energy to shared spaces remains relevant and requires a quality solution. In this video, we'll show you how to build a modular, scalable, autonomous power station with increased capacity. This system can be modified to meet specific needs, providing energy for public spaces and small organizations when electricity is unavailable or unstable due to military actions, disasters, or in remote locations with poor energy infrastructure. The primary target audience for our guide is the administrations of HOAs, homeowners associations, municipal, or other institutions that are unable to utilize industrial-scale equipment. Our product is a step-by-step video instruction for individuals who have basic knowledge in electrical installation work and are capable of safely and competently replicating such a system. The video describes the composition of the system, step-by-step assembly instructions, the sequence of connections, and the necessary safety measures both during installation and in subsequent use. After watching, you will understand how the system functions and how to adapt it to your needs. Let's talk a bit about how the system works. The hybrid inverter allows the station to operate in several modes. First, from photovoltaic modules that generate direct current, DC, the hybrid inverter converts it to alternating current, AC, which is used to power electrical devices in the building, compensating for electrical energy consumption from the grid. Second, in cases where photovoltaic modules do not generate sufficient electrical energy, the hybrid inverter switches to the input grid to ensure stable and uninterrupted operation. This process is automatically controlled by the built-in controller of the hybrid inverter. Third, the hybrid inverter can operate from connected battery storage that stores electrical energy generated by photovoltaic modules. This allows the use of generated electrical energy at any time, including at night or during cloudy weather when photovoltaic modules are not active. When photovoltaic modules generate more energy than needed, the hybrid inverter ensures charging of connected battery storage. At the same time, the built-in controller automatically regulates the battery charge level to ensure their efficient operation. In the absence of grid power, and if solar panels do not generate sufficient energy, the hybrid inverter automatically switches to battery storage. This system is designed for larger facilities than a typical apartment. Its power capacity is sufficient to meet the energy needs of HOAs, municipal institutions, or public organizations. With its help, you can provide power for lighting of shared spaces, as well as video cameras, alarm systems, electromagnetic door locks, routers, etc., for a typical entrance of a 9 to 10-story building. The system consists of photovoltaic modules that convert solar radiation into direct current, DC, electrical energy. A single-phase 6-kilowatt hybrid inverter from Dai, designed to work with 48-volt lithium ferrum phosphate batteries. It converts direct current, DC, into alternating current, AC, providing both backup power and consumption compensation for the connected equipment. A 50 Ah lithium iron phosphate battery from Dynas. A C and DC protection boxes equipped with automatic circuit breakers and surge protective devices. A mounting rack with a set of fasteners, a set of power cables with a 25mm squared cross-section, 2 meters in length, for connecting the battery and connecting the hybrid inverter to the grid and the load. A communication cable needed for the inverter to connect with the battery. An array of 12 photovoltaic modules with a total power of 3.4 kilowatts. A Wi-Fi adapter. For the installation of the system, the following tools are required: insulated screwdriver set, cable cutter, isolation remover, wire stripper, crimping tool for cable lugs, socket wrench set with ratchet handle, combination wrench set, hex key set, multimeter. Please ensure you follow safety regulations during installation. Always use personal protective equipment, PPE, including insulated gloves, safety glasses, and specialized workwear. We mount the inverter on the mounting rack. For this, we use special mountings that come with the kit. The inverter can be mounted either on the wall or on a vertical mounting rack. For this, it's important to choose a rack that can withstand the weight of the mounted equipment. We secure the hanging plate of the inverter on the mounting rack using bolt connections, securely fixing the bolt connection using a ratchet handle with socket head and combination wrench. We hang the hybrid inverter on the hanging plate. We fix the inverter using screws at the ends of the hanging plate using a screwdriver. We install the battery storage. Before its installation, it's essential to ensure that the battery storage is turned off. The battery storage is installed in a specialized mounting location on the mounting rack and secured using combination screws with a screwdriver. Using bolt connections and special mounting locations on the mounting rack, with the help of a ratchet handle with socket head and combination wrench, we securely fix the DC and AC electrical panels. Photovoltaic modules are fixed on the roof or on a special mounting system that will ensure their stability even during strong winds. Make sure all connections are securely fastened. We perform electrical connection of all system elements according to the diagram. This is an important stage so that everything works correctly and safely. It's important to check polarity using a multimeter and record the presence of voltage to avoid connection errors. We prepare the power cable for connecting the battery storage. According to the required length, we cut the battery cables using a cable cutter to include an automatic DC circuit breaker in the break, which is installed in the panel. Using the cable stripping tool, we prepare the cable ends for crimping with cable lugs. We install and crimp cable lugs using the crimping tool. Using a hex key, we open the waterproof plate on the front panel of the inverter. We connect power cables from the battery storage to the DC panel, and from this panel to the inverter. Using a screwdriver, we fix the cable ends in the sockets of the automatic circuit breaker. Through cable entries, we thread cables inside the inverter. Using a screwdriver, we unscrew bolts on the inverter terminals and fix ring lugs of power cables with them. Important. During installation, we control and maintain connection polarity. We prepare power jumper cables for connecting the hybrid inverter to the AC panel, respectively for connecting the system to the electrical grid and connecting to the load. For preparing jumper cables, we use a cable cutter, cable stripping tool, and wire stripper with which individual cable conductors are stripped to a length of 10 millimeters for subsequent crimping with cable lugs. Prepared jumper cables are inserted into the inverter and AC panel. Appropriate connection is made to the inverter's terminal block grid and load, and to corresponding protection devices in the AC panel. For reliable contact fixation, screwdrivers with appropriate tips are used. The current transformer from the grid inverter kit is fixed on the phase conductor after the grid input circuit breaker in the AC panel using a clip. The current transformer is mounted on the conductor so that the arrow on its body points in the direction of current flow to the inverter. Conductors from the current transformer are fed through cable entry into the inverter and connected to corresponding terminals considering marking. A communication cable is connected to the battery storage. Using switches on the front panel of the battery storage, compatibility mode with dye inverter is selected. The communication cable is fed through the corresponding cable entry into the inverter and connected to the BMS-CAN connector. We close the hermetic cover on the front panel of the hybrid inverter and fix it using screws and a hex key. Using a multimeter, we ensure proper voltage presence on MC4 connectors of the solar cable coming from the photovoltaic module array. We connect cables from the photovoltaic module array to the corresponding DC panel at its input using MC4 connectors. The disconnector in this panel should be in the off position. Accordingly, using solar cable from the DC panel, we connect to the hybrid inverter using MC4 connectors that are on the solar cable and grid inverter. We connect the grid cable and the cable that will power the load to the AC panel. The input and output AC circuit breakers should be in the off position. We install the grounding conductor system. The grounding wire should be connected to the housings of all devices on the grid side to prevent electric shock in case of circuit breaker failure. The housings of the hybrid inverter and battery storage are connected to the mounting rack using special jumper conductors that come with the kit. In turn, the mounting rack is connected to the building's grounding system using a flexible conductor with a cross-section of at least 6 square millimeters. On the bottom side of the hybrid inverter, using a screwdriver, we remove the protective plate of the Wi-Fi adapter port. We insert the Wi-Fi adapter into the corresponding inverter socket and fix it using screws. We check the system before startup using a multimeter. We supply voltage to the input of the AC distribution board. Turn on the battery and wait for a certain time until the battery indicators light up. Next, record the voltage reading on the battery's circuit breaker. After checking, close the covers of both the AC and DC distribution boards. Proceed with the first power-up and configuration. Turn on the battery's circuit breaker and supply voltage to the hybrid inverter. Turn on the inverter. Wait for it to start up and become ready for operation. The inverter's status and operational settings can be monitored and adjusted from its control panel. Configure the inverter by setting the date and time, battery type, battery capacity, and appropriate charge and discharge current values. Select the operating mode that allows for self-consumption compensation only, without feeding electricity back into the grid. Turn on the load circuit breaker in the AC distribution board. Check for voltage at the inverter's output in standalone mode. Connect a small load to the inverter, a light bulb. Switch the inverter to operate from the grid. The AC indicator will light up. To check how the system works in autonomous mode, turn off the circuit breaker at the system's input. The light bulb will remain on because the inverter has switched to operating from the battery. Turn on the disconnector in the DC distribution box for the photovoltaic module array and enable the DC voltage supply from them to the inverter. The DC indicator on the panel will light up. Monitor the generated energy supply for battery charging and load consumption compensation. Turn on the electrical grid and simulate a situation where there is no consumption from the grid and the load is powered by energy coming from the photovoltaic modules. Using the mobile app, we can monitor the system's operation in real time via online monitoring. Block diagram of the station's operation showing the energy flow from photovoltaic modules to the inverter and bidirectional flow, charge-discharge, from the battery to the inverter. Self-consumption rate, displayed as daily statistics in percentages and kilowatt hours. Energy source, system power profile, and remaining battery charge in percentages. The application allows you to optimize energy consumption and detect emergency situations in advance. Our system is modular. If there's a need to increase power capacity, additional inverters with photovoltaic modules and battery storage can be connected. This need typically arises when additional building entrances or more consumers are added to the system. It's also possible to provide autonomous operation for an elevator. However, this is a very specific setup, as elevators require specialized equipment that varies depending on the elevator type. Therefore, we don't cover such options in this instruction. Additionally, the hybrid inverter can automatically start a generator as a backup power source. It's crucial that the installation area is properly prepared, with sufficient ventilation and a fire extinguisher readily available. Never work on live circuits. Always check for voltage presence with a multimeter. While performing installation work, always use specialized clothing, safety glasses, and gloves. Double-check cable connections to prevent short circuits. Properly organize your workspace for efficient and safe installation. In case of using equipment different from what's shown in the video, safe starting and proper functioning of the system cannot be guaranteed. This system will be useful for communities facing power supply issues due to military actions, natural disasters, or insufficient grid capacity. It's also beneficial for remote villages in hard-to-reach regions, communities in developing countries, and similar situations. Furthermore, thanks to its modular design, it can be easily modified to meet individual needs in various circumstances. This concludes our tutorial. We've shown you how to properly assemble, connect, configure, and test it. Thank you for choosing our system. We wish you success with your installation and usage.